Question 1. Assessment of which data governance framework best aligns with the foundational requirements for a big data and analytics architecture within a U.S.-based financial services organization, considering the imperative to comply with regulations such as the Gramm-Leach-Bliley Act, GLBA, and the Sarbanes-Oxley Act, SOX. Option A. A framework that integrates regulatory compliance controls, data lineage, access management, and auditability specifically tailored to U.S. financial sector regulations. Option B. A generic data management framework that applies broadly across industries without specific consideration for U.S. financial sector regulatory nuances. Option C. A framework that emphasizes the adoption of the latest open-source big data technologies for maximum flexibility and scalability, with compliance as a secondary consideration. Option D. A framework focused on rapid deployment of analytics solutions to gain market advantage, with data governance addressed post-implementation. Correct answer is A. A framework that integrates regulatory compliance controls, data lineage, access management, and auditability specifically tailored to U.S. financial sector regulations. Explanation. This scenario presents a professional challenge in selecting the most appropriate data governance framework for a financial services organization operating under U.S. regulations, specifically focusing on the implications for big data and analytics architecture. The challenge lies in balancing the need for robust data security and privacy with the desire to leverage advanced analytics for competitive advantage. Careful judgment is required to ensure compliance with stringent regulatory requirements while enabling innovation. The correct approach represents best professional practice because it prioritizes a framework that explicitly addresses the unique challenges of big data and analytics within the U.S. financial regulatory landscape. This involves understanding and integrating requirements from key U.S. regulations such as the Gramm-Leach-Bliley Act, GLBA, for financial privacy, the Sarbanes-Oxley Act, SOX, for financial reporting integrity, and potentially elements of the Health Insurance Portability and Accountability Act, HIPAA, if any health-related financial data is involved, though GLBA and SOX are primary for general financial services. A framework that incorporates principles of data lineage, access control, data quality, and auditability, as mandated or implied by these regulations, is essential. It ensures that the architecture supports compliance by providing mechanisms for data protection, risk management, and transparent reporting, thereby fostering trust and avoiding significant penalties. An incorrect approach that focuses solely on open-source big data technologies without a strong emphasis on regulatory compliance would be professionally unacceptable. This is because it risks violating GLBA safeguards rule by failing to implement adequate security measures for non-public personal information, and SOX's Section 404 by not ensuring the accuracy and reliability of financial data processed through the analytics architecture. Such an approach could lead to data breaches, inaccurate financial reporting, and severe legal and financial repercussions. Another incorrect approach that prioritizes rapid deployment of analytics solutions over comprehensive data governance would also be professionally unsound. This overlooks the critical need for data integrity and security in financial services. Without a robust governance framework, the analytics outputs could be based on flawed or compromised data, leading to incorrect business decisions and potential regulatory violations under SOX. Furthermore, inadequate data protection measures could expose sensitive customer information, violating GLBA. A third incorrect approach that adopts a generic, one-size-fits-all data management strategy without tailoring it to the specific regulatory demands of the U.S. financial sector is also professionally deficient. While generic strategies might cover basic data management principles, they often lack the granular controls and specific compliance mechanisms required by U.S. financial regulations. This could result in gaps in security, privacy, and auditability, leaving the organization vulnerable to regulatory scrutiny and penalties. A professional decision-making process for similar situations should involve a thorough understanding of the applicable regulatory landscape. In this case, U.S. financial regulations like GLBA and SOX. It requires identifying the specific data governance requirements mandated or implied by these regulations. Subsequently, evaluating potential big data and analytics architectures against these requirements, prioritizing solutions that offer built-in compliance features or can be readily adapted to meet them. This involves a risk-based assessment, considering the potential impact of non-compliance and the benefits of a well-governed, compliant analytics environment. Collaboration with legal, compliance, and security teams is paramount throughout this process. Question 2. Comparative studies suggest that organizations often struggle to balance the imperative of leveraging big data for advanced analytics with the stringent requirements of data privacy regulations. Considering a scenario where an organization aims to build a predictive analytics solution using customer transaction data, which architectural approach best safeguards sensitive customer information while enabling effective analysis? Option A. Utilize a highly restrictive data access policy that prevents data scientists from accessing any data that could potentially be linked to individuals, even in an anonymized or pseudonymized state, to eliminate all re-identification risk. Option B. Directly ingest raw customer transaction data into a distributed processing cluster, relying solely on network-level security and access controls at the cluster level to protect sensitive information. Option C. Implement a data lakehouse architecture with robust data anonymization and pseudonymization techniques applied to sensitive fields before broad analytical access, coupled with fine-grained access controls and comprehensive audit trails. Option D. Store all customer transaction data in a traditional relational database and perform analytics by extracting and anonymizing subsets of data on demand for individual analytical queries. The correct answer is C. Implement a data lakehouse architecture with robust data anonymization and pseudonymization techniques applied to sensitive fields before broad analytical access, coupled with fine-grained access controls and comprehensive audit trails. Explanation. Scenario analysis. This scenario presents a common challenge in data architecture, balancing the need for advanced analytics with the imperative to protect sensitive customer data. The professional is tasked with designing a solution that leverages big data technologies for predictive modeling while adhering to stringent data privacy regulations. The challenge lies in identifying the most appropriate architectural pattern that minimizes risk without unduly hindering analytical capabilities. The complexity arises from the potential for data leakage, unauthorized access, and noncompliance with data governance policies, all of which can have severe legal, financial, and reputational consequences. Correct approach analysis. The correct approach involves implementing a data anonymization and pseudonymization strategy within a secure, governed data lakehouse architecture. This aligns with the principles of data minimization and purpose limitation, core tenets of data privacy regulations. By transforming sensitive data into an anonymized or pseudonymized form before it is made broadly accessible for analytics, the risk of re-identification is significantly reduced. A data lakehouse provides a flexible yet structured environment for storing and processing diverse data types, while robust access controls and auditing mechanisms ensure that only authorized personnel can access the data, and only for legitimate analytical purposes. This approach demonstrates a proactive commitment to data protection and regulatory compliance, representing best professional practice by embedding privacy by design. Incorrect approach is analysis. One incorrect approach is to directly ingest and analyze raw, personally identifiable information, PI, in a distributed processing environment without any prior data transformation or robust access controls. This is a direct violation of data privacy principles, as it exposes sensitive data unnecessarily. Regulatory frameworks mandate that data be processed in a manner that ensures appropriate security, including protection against unauthorized or unlawful processing and against accidental loss, destruction, or damage. This approach creates a high risk of data breaches and noncompliance, leading to significant penalties. Another incorrect approach is to rely solely on perimeter security for the data storage and processing environment, assuming that external firewalls and network segmentation are sufficient to protect sensitive data. While important, perimeter security is not a substitute for in-depth data protection measures. Data privacy regulations often require more granular controls, such as encryption at rest and in transit, and access controls at the data element level. This approach fails to address the risk of insider threats or compromised credentials, leaving sensitive data vulnerable even within a seemingly secure network. A third incorrect approach is to implement a rigid, highly restrictive data access policy that prevents data scientists from accessing any data that could potentially be linked to individuals, even in an anonymized form. While caution is necessary, overly restrictive policies can cripple the effectiveness of analytics initiatives, preventing the discovery of valuable insights. The failure here is not in protecting data, but in failing to strike a balance that allows for legitimate, privacy-preserving data utilization. This can lead to missed business opportunities and an inability to derive value from big data investments, indirectly impacting the organization's ability to operate effectively within its competitive landscape. Professional reasoning. Professionals should adopt a risk-based approach to data architecture design, prioritizing data privacy and regulatory compliance from the outset. This involves understanding the specific data privacy regulations applicable to the organization's jurisdiction and the types of data being handled. The process should include a thorough data inventory and classification, identifying sensitive data elements and their associated risks. Architectural decisions should then be guided by principles of privacy by design and by default, incorporating anonymization, pseudonymization, encryption, and robust access controls. Regular audits and reviews of data handling practices are essential to ensure ongoing compliance and to adapt to evolving threats and regulations. Collaboration between data architects, data scientists, legal counsel, and compliance officers is crucial to ensure that all aspects of data governance and privacy are adequately addressed. Question 3. Stakeholder feedback indicates a strong demand for faster deployment of new analytical dashboards and predictive models to gain competitive insights. However, the existing data infrastructure is showing signs of strain, and there are concerns about data quality and security. Which architectural approach best balances the need for agility with the imperative to maintain data integrity and comply with relevant regulations? Option A. Implement a robust data governance framework from the outset, defining data quality rules, access controls, and lineage tracking mechanisms, and integrate these into the design of new data pipelines and analytics solutions. Option B. Expedite the development of new data ingestion pipelines to feed the analytics platforms, deferring detailed data validation and security reviews until after initial deployment to meet stakeholder timelines. Option C. Focus on scaling the data storage and processing infrastructure to accommodate increased data volume, assuming that data quality and security concerns can be addressed as a secondary priority once performance bottlenecks are resolved. Option D. Prioritize the immediate deployment of advanced analytics and machine learning models, ensuring they can access raw data quickly, and address data masking and access control requirements only if specific compliance issues arise later. The correct answer is A. Implement a robust data governance framework from the outset, defining data quality rules, access controls, and lineage tracking mechanisms, and integrate these into the design of new data pipelines and analytics solutions. Explanation. Scenario analysis. This scenario presents a common challenge in data architecture projects, balancing the desire for rapid innovation and feature deployment with the imperative to maintain data integrity and comply with evolving regulatory requirements. The pressure to deliver new analytics capabilities quickly can lead to shortcuts that compromise data quality, security, or governance. Professionals must navigate this tension by prioritizing robust architectural foundations that enable both agility and compliance. The challenge lies in identifying and mitigating risks associated with data ingestion, transformation, and access in a large-scale distributed environment. Correct approach analysis. The correct approach emphasizes establishing a comprehensive data governance framework that is integrated into the architecture from the outset. This includes defining clear data ownership, establishing data quality rules and validation processes, implementing robust security controls, and ensuring auditability of data lineage and access. For the specified exam jurisdiction, assuming U.S. regulations for this example, as no specific jurisdiction was provided in the prompt, and adhering to the strict instruction to use only one. This aligns with principles found in regulations like the Health Insurance Portability and Accountability Act, HIPAA, for protected health information, the Gramm-Leach-Bliley Act, GLBA, for financial data, and general data privacy principles under state laws like the California Consumer Privacy Act, CCPA. By proactively embedding these controls, the architecture supports compliance by design, minimizing the risk of regulatory violations and reputational damage. This approach ensures that data is not only accessible for analytics, but also trustworthy, secure, and managed in accordance with legal and ethical obligations. Incorrect approaches analysis. Implementing a new data ingestion pipeline without a defined data validation strategy poses a significant regulatory risk. This failure to ensure data accuracy and completeness can lead to non-compliance with regulations that mandate accurate reporting and data integrity, such as those requiring accurate financial disclosures or patient record accuracy. It also creates a foundation of untrustworthy data, undermining the value of any analytics derived from it. Prioritizing the immediate deployment of advanced machine learning models without establishing clear access controls and data masking for sensitive information is a critical ethical and regulatory failure. This directly violates data privacy principles and regulations like CCPA or HIPAA, which mandate the protection of personally identifiable information (PI) and protected health information (FI). Such an approach exposes the organization to severe penalties, legal action, and loss of customer trust. Focusing solely on the performance and scalability of data storage solutions while neglecting data lineage tracking and audit trails is another regulatory pitfall. Many regulations require organizations to demonstrate how data was collected, transformed, and used. The absence of lineage makes it impossible to prove compliance, respond to data subject access requests, or investigate data breaches effectively, leading to potential fines and legal complications. Professional reasoning. Professionals should adopt a risk-based compliance by design approach. This involves 1. Understanding the regulatory landscape relevant to the data being handled. 2. Identifying critical data elements and their associated risks. 3. Integrating data governance, security, and privacy controls into the architectural design phase. 4. Implementing continuous monitoring and auditing mechanisms. 5. Fostering a culture of data stewardship and accountability across the organization. When faced with competing priorities, always err on the side of caution regarding regulatory compliance and data integrity. Question 4. To address the challenge of rapidly evolving business requirements for new analytics features while ensuring the integrity and reliability of the underlying data within an IBM big data and analytics architecture, which of the following strategies represents the most robust and professionally sound approach to data quality management? Option A. Implement automated data profiling and validation tools as part of the continuous integration and continuous delivery (CI/CD) pipeline for the data platform, establishing clear data quality metrics and remediation workflows from the outset. Option B. Rely primarily on ad hoc, manual data quality checks performed by individual data analysts on an as-needed basis to validate data used in new analytics features. Option C. Postpone any significant investment in data quality infrastructure and processes, assuming that data issues will be identified and resolved by downstream application users. Option D. Focus solely on delivering new analytics features as quickly as possible, deferring comprehensive data quality assessments and remediation efforts until after the initial deployment phase. The correct answer is A. Implement automated data profiling and validation tools as part of the continuous integration and continuous delivery (CI/CD) pipeline for the data platform, establishing clear data quality metrics and remediation workflows from the outset. Explanation. Scenario analysis. This scenario presents a common challenge in data architecture, balancing the need for rapid innovation and feature development with the imperative to maintain data integrity and comply with evolving regulatory requirements. The pressure to deliver new analytics capabilities quickly can lead to shortcuts in data governance and validation, potentially exposing the organization to risks. The professional challenge lies in advocating for robust data quality processes within a fast-paced development cycle, ensuring that the foundation of the analytics platform is sound before building complex applications on top of it. This requires strong communication skills, an understanding of both business needs and technical risks, and the ability to articulate the long-term consequences of neglecting data quality. Correct approach analysis. The correct approach emphasizes a proactive and integrated strategy for data quality management. This involves establishing clear data quality standards, implementing automated data profiling and validation tools early in the data ingestion and transformation pipeline, and fostering a culture of data ownership and accountability. By embedding data quality checks into the CI/CD pipeline for the data platform, the team ensures that data issues are identified and remediated as close to the source as possible, preventing the propagation of errors into downstream analytics and reporting. This aligns with best practices in data governance and risk management, ensuring that the data underpinning IBM big data and analytics solutions is reliable, accurate, and fit for purpose. This approach minimizes the risk of regulatory noncompliance due to inaccurate reporting or data breaches stemming from poorly managed data. Incorrect approaches analysis. One incorrect approach involves prioritizing the immediate deployment of new analytics features without adequate data validation. This creates a significant risk of generating inaccurate insights, leading to flawed business decisions and potential regulatory scrutiny if those insights are used for compliance reporting or customer-facing applications. It also increases the technical debt associated with the data platform, making future remediation efforts more complex and costly. Another incorrect approach is to defer data quality remediation to a later stage, after the analytics features have been deployed. This is problematic because data quality issues can be deeply embedded in historical data and complex transformation logic, making them difficult and time-consuming to fix retrospectively. This delay can also mean that critical business decisions are being made on faulty data for an extended period, with potentially severe consequences. A third incorrect approach is to rely solely on manual data quality checks performed by individual analysts. While manual checks can be useful for specific, ad hoc investigations, they are not scalable or sustainable for a large-scale big data and analytics architecture. This approach is prone to human error, inconsistency, and a lack of comprehensive coverage, leaving significant gaps in data integrity and increasing the likelihood of undetected data quality problems. Professional reasoning. Professionals should adopt a risk-based approach to data quality. This involves identifying critical data elements and processes that have the highest impact on business operations and regulatory compliance. They should then implement a layered strategy for data quality, combining automated checks at various stages of the data lifecycle with robust data governance policies and procedures. Continuous monitoring and a feedback loop for data quality issues are essential. When faced with pressure to accelerate development, professionals must clearly articulate the risks associated with compromising data quality and advocate for the necessary resources and time to implement sound data governance practices. This involves understanding the business context, the potential impact of data errors, and the regulatory landscape to make informed decisions that protect the organization. Question 5. Benchmark analysis indicates that a financial services firm is experiencing significant delays in deriving actionable insights from its customer transaction data due to a perceived lack of readily accessible raw data for its data science team. The firm's chief data officer, CDO, is under pressure to accelerate the analytics pipeline. The data science team has proposed immediate, broad access to all customer transaction tables, including personally identifiable information, PI, to expedite their work. Which of the following approaches best balances the need for rapid insight generation with the imperative of regulatory compliance and data security? Option A. Prioritize the immediate deployment of analytics tools and provide access to raw data, deferring the implementation of comprehensive data governance and security protocols until after the initial insights are generated. Option B. Implement a phased approach that includes robust data anonymization or pseudonymization techniques for sensitive fields, establish strict role-based access controls, and conduct thorough security reviews of the analytics environment before granting access to any data. Option C. Rely on individual data scientists to self-regulate their access and handling of sensitive customer transaction data, assuming they understand and will adhere to all relevant data privacy policies. Option D. Grant the data science team unrestricted, direct access to all raw customer transaction tables, including PII, to allow them to perform their analysis without delay. The correct answer is B. Implement a phased approach that includes robust data anonymization or pseudonymization techniques for sensitive fields, establish strict role-based access controls, and conduct thorough security reviews of the analytics environment before granting access to any data. Explanation. Scenario analysis. This scenario presents a common challenge in data governance, where the perceived immediate business need for rapid data access clashes with the foundational principles of data security and compliance. The pressure to deliver insights quickly can lead to shortcuts that bypass established protocols, potentially exposing sensitive information or violating data privacy regulations. The challenge lies in balancing agility with responsibility, ensuring that the pursuit of analytics does not compromise the integrity or security of the data. Correct approach analysis. The correct approach emphasizes a phased implementation that prioritizes data security and compliance from the outset. This involves establishing clear data access policies, implementing robust anonymization or pseudonymization techniques where appropriate, and ensuring that the chosen analytics platform is configured to meet regulatory requirements for data handling and storage. This aligns with the principles of data minimization and purpose limitation, ensuring that data is only accessed and processed for legitimate, defined purposes, and that appropriate safeguards are in place. This proactive, compliance-by-design approach is best professional practice as it mitigates risks, builds trust with data subjects, and avoids costly remediation efforts later. It directly addresses the foundational requirements of data architecture for big data and analytics by embedding security and governance into the design. Incorrect approach is analysis. One incorrect approach involves granting broad, unrestricted access to raw, sensitive data to all data scientists. This is a significant regulatory and ethical failure. It violates data privacy principles by exposing personal or confidential information without adequate justification or safeguards. This could lead to breaches of regulations like GDPR, if applicable to the exam's jurisdiction. Assuming a U.S. context for this example, it would be similar principles under CCPA or HIPAA, depending on data type, or internal company policies, resulting in severe penalties, reputational damage, and loss of customer trust. Another incorrect approach is to delay the implementation of data governance and security controls until after the initial analytics project is completed. This is a reactive and high-risk strategy. It creates a window of vulnerability where data could be misused or compromised. Ethically, it demonstrates a disregard for data protection responsibilities. From a regulatory standpoint, it can be seen as negligence, as compliance should be an ongoing process, not an afterthought. This approach fails to adhere to the foundational principles of building secure and compliant data architectures. A third incorrect approach is to rely solely on the data scientist's individual discretion to handle sensitive data appropriately. While individual responsibility is important, it is insufficient as a sole control mechanism. This approach lacks the necessary oversight and standardized procedures to ensure consistent adherence to regulations and best practices. It creates a high risk of human error or varying interpretations of data handling requirements, leading to potential breaches and non-compliance. It fails to establish a robust governance framework, which is a cornerstone of responsible big data and analytics architecture. Professional reasoning. Professionals should adopt a risk-based, compliance-first mindset when designing and implementing big data and analytics architectures. This involves understanding the regulatory landscape relevant to the data being handled, identifying potential risks, and embedding security and governance controls into every stage of the data lifecycle. A structured approach, starting with clear data classification, defining access policies, and implementing appropriate technical safeguards, is crucial. Regular audits and reviews should be conducted to ensure ongoing compliance and adapt to evolving threats and regulations. The decision-making process should prioritize data protection and ethical consideration, ensuring that business objectives are met without compromising these fundamental requirements. Question 6. Consider a scenario where an organization plans to deploy a new advanced analytics platform to gain deeper insights into customer behavior, predict market trends, and personalize customer experiences. The platform will ingest vast amounts of customer data, including purchase history, browsing patterns, and demographic information. Before full implementation, what is the most appropriate and legally compliant approach to ensure the privacy of customer data and mitigate potential risks? Option A. Proceed with the platform's deployment and address any privacy concerns that emerge during or after the implementation phase. Option B. Rely solely on existing general IT security policies to protect customer data, assuming they are sufficient for advanced analytics. Option C. Conduct a comprehensive data protection impact assessment (DPIA) to systematically identify and evaluate privacy risks and define mitigation strategies. Option D. Anonymize all customer data before ingestion into the analytics platform, and consider this sufficient for privacy protection. The correct answer is C. Conduct a comprehensive data protection impact assessment (DPIA) to systematically identify and evaluate privacy risks and define mitigation strategies. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent tension between leveraging advanced analytics for business advantage and the imperative to comply with data privacy regulations. The organization's desire to gain competitive insights from customer data, while laudable from a business perspective, must be carefully balanced against the legal and ethical obligations to protect individual privacy. The complexity arises from identifying and mitigating potential risks associated with data usage, especially when dealing with large, diverse datasets that could inadvertently reveal sensitive information or lead to discriminatory outcomes. A failure to conduct a thorough impact assessment can lead to significant legal penalties, reputational damage, and erosion of customer trust. Correct approach analysis. The correct approach involves conducting a comprehensive data protection impact assessment, DPIA, prior to the deployment of the new analytics platform. This aligns with the principles of data protection by design and by default, as mandated by regulations like the GDPR, General Data Protection Regulation, which is a foundational framework for data privacy globally and relevant to understanding such architectural considerations. A DPIA systematically identifies and assesses the risks to individuals' rights and freedoms arising from data processing activities. It requires a detailed understanding of the data to be processed, the purposes of processing, the necessity and proportionality of the processing, and the measures to be taken to mitigate identified risks. This proactive approach ensures that privacy considerations are embedded into the architecture from the outset, rather than being an afterthought. It demonstrates a commitment to responsible data stewardship and regulatory compliance, fostering trust with customers and stakeholders. Incorrect approach is analysis. Implementing the analytics platform without a formal impact assessment, relying solely on general IT security policies, is a significant regulatory and ethical failure. General IT security policies often focus on technical safeguards against breaches, but may not adequately address the broader privacy implications of data usage, such as the potential for re-identification or the creation of biased algorithms. This approach neglects the specific requirements of data protection laws that mandate risk assessments for high-risk processing activities. Proceeding with the deployment and addressing privacy concerns only if they arise during or after implementation is also a failure. This reactive stance is contrary to the principles of data protection by design and by default. It significantly increases the likelihood of noncompliance, as potential risks may not be identified or mitigated in time, leading to breaches of privacy rights and subsequent regulatory action. It also demonstrates a lack of due diligence and a disregard for the potential harm to individuals. Focusing solely on anonymizing the data without a broader impact assessment is insufficient. While anonymization is a crucial privacy-enhancing technique, it is not a panacea. The effectiveness of anonymization can be compromised, and even anonymized data, when combined with other datasets, can sometimes be re-identified. A comprehensive impact assessment would consider the limitations of anonymization and explore other necessary safeguards and legal bases for processing. Professional reasoning. Professionals in data architecture must adopt a risk-based approach to data processing. This involves understanding the regulatory landscape, identifying potential privacy risks associated with proposed data uses, and implementing appropriate safeguards. The decision-making process should prioritize compliance and ethical considerations alongside business objectives. When faced with new data processing initiatives, a structured impact assessment, such as a DPIA, should be the first step. This assessment should involve relevant stakeholders, including legal and privacy experts, to ensure all potential risks are identified and addressed. The outcome of the assessment should inform the design and implementation of the data architecture, ensuring that privacy is a core consideration throughout the lifecycle of the data and the systems that process it. Question 7. The investigation demonstrates that a critical IBM big data and analytics architecture component is experiencing significant latency in its data ingestion and transformation stages, impacting the timeliness of downstream analytical reports. The architecture team is tasked with optimizing this process. Which of the following approaches best balances the need for improved processing speed with the imperative to maintain data integrity, security, and regulatory compliance? Option A. Implement aggressive data compression techniques and parallel processing across all data nodes, prioritizing raw throughput above all other considerations. Option B. Introduce a new, faster data ingestion tool that bypasses existing data validation checks to accelerate the initial loading process. Option C. Conduct a thorough review of the data pipeline, identifying bottlenecks and opportunities for optimization, while ensuring that all changes maintain robust data lineage, audit trails, and adherence to established security protocols and data governance policies. Option D. Focus solely on reducing the number of transformation steps, even if it means simplifying data cleansing and enrichment processes. The correct answer is A. Implement aggressive data compression techniques and parallel processing across all data nodes, prioritizing raw throughput above all other considerations. Explanation: the investigation demonstrates a common challenge in large-scale data analytics projects: the tension between achieving optimal processing efficiency and adhering to data governance principles. In this scenario, the challenge lies in balancing the need for rapid data ingestion and transformation to support real-time analytics with the imperative to maintain data integrity, security, and compliance with regulatory requirements. Professionals must exercise careful judgment to ensure that process optimization efforts do not inadvertently compromise these critical aspects. The correct approach represents best professional practice because it prioritizes a holistic view of process optimization. It acknowledges that true efficiency is not solely about speed, but also about the reliability, security, and compliance of the data processing pipeline. By integrating data governance and security considerations from the outset, this approach ensures that optimization efforts are sustainable and do not create future risks or compliance issues. This aligns with the foundational principles of responsible data management, which are implicitly or explicitly supported by regulatory frameworks governing data handling and privacy. An incorrect approach that focuses solely on raw processing speed without considering data lineage and auditability would be professionally unacceptable. This failure would violate the principle of data integrity, making it impossible to trace data transformations or identify the source of errors, which is often a requirement for regulatory compliance and internal audits. Another incorrect approach that bypasses security protocols for faster data access would represent a significant ethical and regulatory failure. This could lead to data breaches, unauthorized access, and noncompliance with data protection laws, exposing the organization to severe penalties and reputational damage. A third incorrect approach that ignores the impact of optimization on data quality would also be flawed, as it could lead to inaccurate insights and flawed decision-making, undermining the very purpose of the analytics architecture. Professionals should employ a decision-making framework that begins with a clear understanding of the business objectives and the regulatory landscape. This involves identifying key performance indicators for process optimization that include not only speed, but also data quality, security, and compliance. The next step is to evaluate potential optimization strategies against these criteria, using a risk-based approach. This means prioritizing solutions that offer significant efficiency gains while posing minimal risk to data integrity, security, and compliance. Continuous monitoring and iterative refinement are also crucial, ensuring that optimization efforts remain aligned with evolving business needs and regulatory requirements. Question 8. Consider a scenario where a financial services firm is building a new big data analytics platform to identify fraudulent transactions. The platform will ingest vast amounts of customer transaction data, including account numbers, transaction amounts, merchant details, and timestamps. To maximize the potential for uncovering complex fraud patterns, the architecture team proposes storing all raw, anonymized customer transaction data in a central data lake, relying solely on strict access controls to protect sensitive information. A compliance officer raises concerns about potential violations of data privacy regulations. Which of the following approaches best addresses the regulatory and ethical considerations for this big data architecture? Option A. Encrypt all data at rest within the data lake and implement multi-factor authentication for all users accessing the platform, without altering the raw data itself. Option B. Limit the scope of data ingested into the data lake to only aggregated transaction summaries, excluding any individual customer transaction details, thereby reducing the volume of sensitive data. Option C. Store all raw, unanonymized customer transaction data in the data lake and rely exclusively on stringent role-based access controls to prevent unauthorized access to sensitive information. Option D. Implement robust data anonymization and pseudonymization techniques at the data ingestion layer, transforming sensitive customer identifiers before storing data in the data lake, and then applying access controls to the pseudonymized data. The correct answer is D. Implement robust data anonymization and pseudonymization techniques at the data ingestion layer, transforming sensitive customer identifiers before storing data in the data lake, and then applying access controls to the pseudonymized data. Explanation. This scenario presents a professional challenge due to the inherent tension between leveraging advanced analytics for business insights and adhering to stringent data privacy regulations. The core difficulty lies in balancing the desire for comprehensive data analysis with the legal and ethical obligations to protect sensitive customer information. Careful judgment is required to ensure that the architecture and implementation of the big data solution do not inadvertently lead to non-compliance. The correct approach represents best professional practice because it proactively embeds privacy by design principles into the big data architecture. This involves implementing robust data anonymization and pseudonymization techniques at the ingestion and processing stages. By transforming personally identifiable information, PI, into less sensitive forms before it is extensively analyzed or stored in aggregated datasets, the organization significantly reduces the risk of data breaches involving sensitive information. This aligns with the principles of data minimization and purpose limitation, which are fundamental to many data protection frameworks, ensuring that data is only collected and processed for specified, explicit, and legitimate purposes, and is not further processed in a manner that is incompatible with those purposes. An incorrect approach that involves storing raw, unanonymized customer data in a central data lake for broad analytical purposes poses significant regulatory and ethical failures. This directly violates principles of data minimization and purpose limitation, as it collects and retains more data than is strictly necessary for immediate, defined analytical tasks. Furthermore, it creates an unacceptable risk of unauthorized access or disclosure of PII, which could lead to severe penalties under data protection laws, reputational damage, and loss of customer trust. Another incorrect approach, focusing solely on access controls after data ingestion without implementing data transformation, is also professionally unacceptable. While access controls are a necessary component of data security, they are not sufficient on their own to guarantee compliance when dealing with sensitive raw data. If a breach occurs or an insider misuses access, the raw PII remains exposed. This approach fails to address the inherent risk within the data itself, making it vulnerable even with strong security measures. The professional reasoning process for similar situations should involve a multifaceted risk assessment. First, identify all sensitive data elements and understand their regulatory implications. Second, evaluate the intended analytical use cases and determine the minimum data required to achieve those objectives. Third, design the data architecture with privacy-enhancing technologies and techniques like anonymization, pseudonymization, differential privacy, integrated from the outset. Fourth, implement layered security controls, including robust access management, encryption, and auditing. Finally, establish clear data governance policies and conduct regular compliance audits to ensure ongoing adherence to regulations and ethical standards. Question 9. The investigation demonstrates that a financial services firm operating under U.S. regulations is developing a new customer analytics platform. The platform aims to leverage historical transaction data, demographic information, and customer interaction logs to personalize product offerings and improve customer service. However, the initial architectural design proposals present varying approaches to handling sensitive customer personally identifiable information, PI. Which architectural approach best aligns with the principles of data privacy and security mandated by U.S. regulatory frameworks for such a platform? Option A. Design an architecture that centralizes all raw customer PII in a secure data lake, relying solely on robust encryption for data at rest and in transit, and obtaining broad, general consent from customers for all potential future data analysis. Option B. Build an architecture that ingests all available customer data, including sensitive PII, without explicit anonymization or pseudonymization, assuming that strong network security will prevent unauthorized access, and documenting the data usage in a general privacy policy. Option C. Develop a system that focuses on collecting extensive customer data for future, undefined analytical needs, with the primary security measure being a single, high-level access credential for the entire analytics team. Option D. Implement a data architecture that prioritizes data minimization by collecting and storing only the PII strictly necessary for the defined analytical purposes, employing pseudonymization techniques for data used in analytics, and enforcing role-based access controls with strict audit trails for all data access. The correct answer is D. Implement a data architecture that prioritizes data minimization by collecting and storing only the PII strictly necessary for the defined analytical purposes, employing pseudonymization techniques for data used in analytics, and enforcing role-based access controls with strict audit trails for all data access. Explanation. The investigation demonstrates a common challenge in big data and analytics architecture, balancing the need for data utilization with stringent regulatory compliance. Specifically, the scenario highlights the critical importance of data privacy and security, particularly when dealing with sensitive customer information. The professional challenge lies in designing and implementing data architectures that enable advanced analytics for business insights, while adhering to the specific data protection regulations applicable to the jurisdiction. This requires a deep understanding of the data lifecycle, potential risks, and the legal obligations. The correct approach represents best professional practice because it prioritizes a privacy-by-design methodology. This involves embedding data protection principles into the architecture from its inception, rather than attempting to retrofit compliance measures later. By anonymizing or pseudonymizing data where appropriate, implementing robust access controls, and ensuring data minimization, the architecture directly addresses the core tenets of data privacy regulations. This proactive stance not only mitigates legal and financial risks, but also builds customer trust and upholds ethical data handling standards. An incorrect approach that involves storing raw, identifiable customer data without adequate anonymization or pseudonymization, and without robust, granular access controls, represents a significant regulatory failure. This directly contravenes data protection principles that mandate the protection of personal information and limit its processing to necessary purposes. Such an approach exposes the organization to substantial fines, reputational damage, and potential legal action for data breaches or misuse. Another incorrect approach, which focuses solely on technical security measures like encryption at rest and in transit, while important, is insufficient on its own. It fails to address the fundamental privacy requirements of data minimization and purpose limitation. Without considering what data is collected, and why even encrypted data can be processed in a non-compliant manner, leading to ethical and regulatory breaches. A third incorrect approach, which relies on obtaining broad, non-specific consent for data usage, is also professionally unacceptable. Modern data protection regulations often require granular, informed consent for specific data processing activities. Broad consent can be deemed invalid, leaving the organization vulnerable to accusations of data misuse and violating the principle of transparency. The professional decision-making process for similar situations should involve a multidisciplinary approach. It begins with a thorough understanding of the applicable regulatory framework, such as GDPR or CCPA, depending on the jurisdiction. This understanding must then be translated into architectural design principles. Key considerations include data classification, risk assessment, data minimization, purpose limitation, and the implementation of appropriate technical and organizational measures for data protection. Continuous monitoring and auditing of the data architecture and its usage are also crucial to ensure ongoing compliance and adapt to evolving regulations and threats. Question 10. Upon reviewing the proposed architecture for a new customer analytics platform that will ingest data from multiple sources, including transactional records and social media interactions, what is the most critical regulatory consideration to ensure compliance with data privacy frameworks? Option A. Implementing robust data anonymization techniques that render personal data irreversibly unidentifiable for integration into the analytics environment, coupled with a clear data governance policy that enforces purpose limitation and data minimization. Option B. Prioritizing the collection of the widest possible range of customer data to enable comprehensive behavioral analysis, assuming that anonymization will be applied post-integration. Option C. Focusing solely on the technical aspects of data security, such as encryption and access controls, without a specific strategy for data anonymization or consent management. Option D. Relying on the implicit consent of customers based on their existing terms of service agreements to process their data for analytics purposes, without seeking explicit consent for this new platform. The correct answer is A. Implementing robust data anonymization techniques that render personal data irreversibly unidentifiable before integration into the analytics environment, coupled with a clear data governance policy that enforces purpose limitation and data minimization. Explanation. This scenario presents a common challenge in big data and analytics architecture, balancing the need for data utilization with stringent regulatory compliance. The professional challenge lies in interpreting and applying complex data privacy regulations to a novel data processing initiative, ensuring that the architecture design not only meets business objectives, but also avoids significant legal and reputational risks. Careful judgment is required to navigate the nuances of data anonymization, consent management, and data minimization principles as mandated by relevant frameworks. The correct approach represents best professional practice because it proactively embeds privacy by design principles into the architecture. This involves a thorough assessment of data sensitivity, the implementation of robust anonymization techniques that are demonstrably effective against re-identification risks, and the establishment of clear data governance policies that align with regulatory mandates. By prioritizing data minimization and purpose limitation, the architecture ensures that only necessary data is collected and processed for clearly defined purposes, thereby adhering to core tenets of data protection regulations. This proactive stance minimizes the likelihood of breaches, unauthorized access, and noncompliance penalties, fostering trust with data subjects and stakeholders. An incorrect approach that fails to adequately anonymize sensitive personal data before integration into the analytics platform poses a direct regulatory failure. This violates principles of data minimization and purpose limitation, as sensitive information is exposed without sufficient safeguards. Such an approach could lead to significant fines under data protection laws and severe reputational damage. Another incorrect approach that bypasses the need for explicit consent for secondary data usage, even if anonymized, risks violating consent requirements. Regulations often stipulate that consent must be informed, specific, and freely given, and using data for purposes beyond the original consent, even after anonymization, can be problematic if not properly addressed through reconsent or a clear legal basis. A third incorrect approach that focuses solely on technical anonymization, without considering the broader data governance and lifecycle management aspects, overlooks the holistic nature of regulatory compliance. Data governance ensures accountability, auditability, and ongoing adherence to privacy policies throughout the data's existence, which is critical for sustained compliance. Professionals should employ a decision-making framework that begins with a comprehensive understanding of the applicable regulatory landscape. This involves identifying all relevant data protection laws and guidelines. Subsequently, a thorough data inventory and classification exercise should be conducted to understand the types of data being processed, their sensitivity, and their sources. This should be followed by a risk assessment to identify potential privacy risks associated with the proposed architecture and data processing activities. Based on this assessment, appropriate technical and organizational measures, such as anonymization, pseudonymization, access controls, and consent management mechanisms, should be designed and implemented. Continuous monitoring, auditing, and regular review of the architecture and data processing practices against evolving regulatory requirements are essential for maintaining compliance and mitigating risks. Question 11. Benchmark analysis indicates that an organization is planning to leverage a third-party cloud provider for storing and processing large volumes of customer data for advanced analytics. The organization operates within a jurisdiction with strict data privacy regulations. Which of the following architectural approaches best ensures compliance with these regulations while enabling effective data utilization? Option A. Integrate all customer data directly into the cloud environment without any prior data sanitization or privacy controls trusting the cloud provider's inherent security to protect the data. Option B, proceed with data ingestion and analysis, relying solely on the cloud provider's standard security measures and assuming all customer data is non-sensitive for analytical purposes. Option C, focus primarily on the performance and scalability of the analytics platform, with data privacy and security being secondary considerations, addressed only if regulatory issues arise. Option D, implement robust data anonymization and pseudonymization techniques, establish strict access controls and audit trails, conduct a data privacy impact assessment, and ensure the cloud provider meets specific, verifiable security and privacy standards contractually. The correct answer is D. Implement robust data anonymization and pseudonymization techniques, establish strict access controls and audit trails, conduct a data privacy impact assessment, and ensure the cloud provider meets specific, verifiable security and privacy standards contractually. Explanation. Scenario analysis. This scenario presents a common challenge in big data and analytics architecture, balancing the need for data utilization with stringent regulatory compliance, specifically concerning data privacy and security. The challenge lies in identifying and implementing appropriate technical and organizational measures to protect sensitive customer data while still enabling valuable analytics. The organization's reliance on a third-party cloud provider for data storage and processing introduces an additional layer of complexity, requiring careful due diligence and contractual agreements to ensure the provider adheres to the same regulatory standards. Failure to do so can lead to significant legal penalties, reputational damage, and loss of customer trust. Correct approach analysis. The correct approach involves a multifaceted strategy that prioritizes data governance and security from the outset. This includes implementing robust data anonymization and pseudonymization techniques to reduce the risk of re-identification, establishing clear data access controls and audit trails to monitor data usage, and ensuring the chosen cloud provider has undergone independent security certifications and audits relevant to the specified jurisdiction's data protection laws. Furthermore, a comprehensive data privacy impact assessment, DPIA, is crucial to identify and mitigate potential risks before data processing begins. This approach aligns with the principles of data minimization, purpose limitation, and security by design, which are fundamental to regulatory frameworks like GDPR. Assuming this is the relevant jurisdiction for the exam, as it's a common global standard for data privacy. Incorrect approaches analysis. One incorrect approach would be to proceed with data integration and analysis without a thorough understanding of the data's sensitivity and without implementing any privacy-enhancing technologies. This directly violates the principle of data protection by design and default, and potentially leads to unauthorized access or disclosure of personal data, resulting in regulatory fines and legal action. Another incorrect approach is to solely rely on the cloud provider's general security assurances without conducting independent verification or establishing specific contractual obligations for data protection. This abdicates responsibility for data security and privacy, making the organization liable for any breaches or noncompliance by the provider. A third incorrect approach is to assume that all data is non-sensitive and can be freely analyzed, ignoring the potential for re-identification through aggregation or linkage with other datasets. This demonstrates a lack of due diligence and a disregard for the potential privacy implications of big data analytics. Professional reasoning. Professionals tasked with designing big data and analytics architectures must adopt a proactive and risk-aware mindset. The decision-making process should begin with a comprehensive understanding of the data landscape, including the types of data being collected, their sensitivity, and the applicable regulatory requirements of the relevant jurisdiction. This should be followed by a thorough risk assessment, identifying potential threats to data privacy and security. Based on this assessment, appropriate technical and organizational controls should be designed and implemented, prioritizing privacy-enhancing technologies and robust security measures. Continuous monitoring, auditing, and regular reviews of the architecture and its compliance posture are essential to adapt to evolving threats and regulatory changes. Engaging legal and compliance experts early in the design process is also critical to ensure all regulatory obligations are met. Question 12. Examination of the data shows that a financial services organization is planning to implement a new big data analytics platform to gain insights into customer behavior and market trends. The organization operates under strict financial data privacy regulations that mandate the protection of personally identifiable information, PI, and sensitive financial details. The proposed architecture involves ingesting large volumes of raw customer transaction data, including account numbers, transaction amounts, and customer names, into a central data lake. The analytics team requires access to this data for developing predictive models. Which of the following architectural approaches best ensures regulatory compliance while enabling effective analytics? Option A. Implement robust data masking and anonymization techniques at the point of data ingestion and during data processing, ensuring that sensitive fields are de-identified before being made available for general analytical use, with a clear audit trail of data transformations. Option B. Defer all data de-identification and anonymization processes until after the analytical models have been developed and insights have been extracted, with a plan for retrospective data sanitization. Option C. Focus on implementing comprehensive post-analysis audit trails and security monitoring of the data lake, assuming that the analytics team will adhere to ethical data handling practices without explicit architectural controls for data de-identification. Option D. Grant broad access to the raw data lake for the analytics team, relying on strict access control lists, ACL, and user permissions to prevent unauthorized access to sensitive information. The correct answer is A. Implement robust data masking and anonymization techniques at the point of data ingestion and during data processing, ensuring that sensitive fields are de-identified before being made available for general analytical use, with a clear audit trail of data transformations. Explanation. This scenario presents a common challenge in big data architecture, balancing the need for data accessibility and analytical insight with stringent regulatory compliance requirements. The professional challenge lies in interpreting and applying the specific mandates of the relevant regulatory framework to a complex, multifaceted data environment. Careful judgment is required to ensure that the chosen architectural approach not only facilitates effective data analysis, but also demonstrably adheres to all legal and ethical obligations concerning data privacy, security, and governance. The correct approach represents best professional practice because it prioritizes a proactive, risk-based strategy for data governance and security. By implementing robust data masking and anonymization techniques at the ingestion and processing stages, it directly addresses the core regulatory concerns of protecting sensitive information while still enabling valuable analytics. This aligns with the principles of data minimization and privacy by design, which are fundamental to many data protection regulations. The architecture ensures that only necessary and appropriately de-identified data is used for analysis, thereby minimizing the risk of breaches and non-compliance. An incorrect approach that focuses solely on broad access controls without granular data protection mechanisms fails to adequately address the specific requirements of data privacy regulations. This could lead to inadvertent exposure of personally identifiable information, PI, or sensitive data, resulting in significant regulatory penalties and reputational damage. Another incorrect approach that delays data de-identification until after analysis is highly problematic. This significantly increases the risk surface, as sensitive data is handled and potentially exposed during the entire analytical lifecycle. Such a delay would likely violate principles of data minimization and purpose limitation, as data is retained in its sensitive form for longer than necessary. An approach that relies on post hoc audits without embedding compliance into the architecture itself is also flawed. While audits are important, they are reactive. A truly compliant architecture should be designed with compliance as a foundational element, not an afterthought. The professional reasoning process for similar situations should involve a thorough understanding of the applicable regulatory landscape, a comprehensive assessment of the data types and their sensitivity, and a risk-based evaluation of potential architectural solutions. This includes engaging with legal and compliance experts early in the design phase, prioritizing privacy by design principles, and continuously monitoring and adapting the architecture to evolving regulatory requirements and technological advancements. Question 13. Performance analysis shows that a retail company is experiencing significant growth in customer data volume and complexity. To enhance personalized marketing campaigns and improve customer retention, the company plans to implement a new big data analytics platform. This platform will integrate data from various sources, including online purchases, in-store transactions, social media interactions, and customer service logs. The primary objective is to derive actionable insights into customer behavior patterns. However, the company operates in a jurisdiction with strict data privacy regulations that govern the collection, processing, and storage of personal data. The architecture team is tasked with designing the big data analytics solution while ensuring full compliance with these regulations. Which of the following approaches best balances the company's analytical objectives with regulatory compliance? Option A. Prioritize the speed of deployment and the breadth of analytical features, assuming that existing general IT security policies will adequately cover data privacy requirements for the new big data environment. Option B. Focus on maximizing the volume and variety of data ingested into the platform to ensure comprehensive customer profiling and address any privacy concerns through anonymization techniques applied only after the data has been extensively analyzed. Option C. Implement the big data analytics platform with advanced analytical capabilities and then conduct a post-implementation audit to identify and address any potential privacy gaps. Option D. Design and build the big data analytics platform with privacy by design principles embedded from the outset, including data minimization, purpose limitation, and robust security measures, and conduct a data protection impact assessment (DPIA) before deployment. The correct answer is C. Implement the big data analytics platform with advanced analytical capabilities, and then conduct a post-implementation audit to identify and address any potential privacy gaps. Explanation: this scenario presents a professional challenge due to the inherent tension between leveraging advanced analytics for business insights and adhering to stringent data privacy regulations. The organization's goal of optimizing customer engagement through big data analytics must be balanced against the legal and ethical obligations to protect sensitive customer information. Careful judgment is required to ensure that the pursuit of business objectives does not inadvertently lead to non-compliance, reputational damage, or legal penalties. The correct approach represents best professional practice because it prioritizes a proactive and integrated strategy for regulatory compliance within the big data architecture. By embedding privacy by design principles and conducting thorough data impact assessments, the organization demonstrates a commitment to responsible data handling. This aligns with the spirit and letter of data protection laws, which increasingly emphasize accountability and the minimization of data processing risks. Specifically, this approach ensures that data collection, storage, processing, and sharing activities are conducted in a manner that respects individual privacy rights and meets legal requirements for consent, transparency, and security. An incorrect approach that focuses solely on the technical implementation of analytics without considering regulatory implications is professionally unacceptable. This failure stems from a disregard for data protection laws, which mandate specific controls and safeguards. Such an approach risks unauthorized data access, inappropriate data usage, and potential breaches, leading to significant fines and legal action. Another incorrect approach that relies on retrospective compliance checks after the analytics solution is deployed is also professionally flawed. This reactive stance fails to address potential risks early in the development lifecycle, making remediation more complex and costly. It also demonstrates a lack of due diligence and a failure to embed compliance as a core requirement, which is a violation of the principles of responsible data governance. The professional decision-making process for similar situations should involve a multidisciplinary team including data architects, legal counsel, compliance officers, and business stakeholders. This team should establish clear data governance policies that integrate regulatory requirements from the outset. A risk-based approach, involving regular data protection impact assessments and ongoing monitoring, is crucial. Furthermore, fostering a culture of data privacy awareness and providing continuous training to all personnel involved in data handling are essential components of responsible big data architecture. Question 14. The monitoring system demonstrates a significant increase in the volume and variety of data being ingested, including user interaction logs and system performance metrics. Given the potential for this data to contain sensitive information, Which of the following approaches best ensures compliance with U.S. federal data privacy and security regulations while enabling effective analytics? Option A. Anonymize all ingested data at the point of collection without a clear understanding of the analytical requirements, potentially hindering the ability to derive meaningful insights. Option B. Implement a data governance framework that includes data classification, access controls based on the principle of least privilege, and regular privacy impact assessments for all data sources feeding the monitoring system. Option C. Rely on vendor-provided security features of the big data platform without conducting an independent assessment of their adequacy against specific regulatory requirements. Option D. Focus solely on optimizing the performance and scalability of the monitoring system to handle the increased data load, assuming that standard IT security measures are sufficient. The correct answer is B. Implement a data governance framework that includes data classification, access controls based on the principle of least privilege, and regular privacy impact assessments for all data sources feeding the monitoring system. Explanation. This scenario presents a professional challenge due to the inherent tension between leveraging advanced analytics for business insights and the stringent regulatory requirements surrounding data privacy and security. The organization must ensure that its big data architecture, including the monitoring system, not only performs optimally, but also adheres strictly to the specified regulatory framework. The chosen jurisdiction for this exam is U.S. federal regulations, particularly those impacting data handling and privacy. The correct approach represents best professional practice because it prioritizes a proactive, risk-based strategy that integrates regulatory compliance directly into the architecture and operational processes. This involves understanding the specific data types being monitored, identifying potential privacy risks, and implementing appropriate technical and organizational safeguards. By embedding privacy by design principles and conducting regular audits, the organization demonstrates a commitment to responsible data stewardship, which is a cornerstone of U.S. data protection laws like HIPAA for health data or general principles under FTC oversight for consumer data. This approach minimizes the likelihood of breaches, unauthorized access, and noncompliance penalties. An incorrect approach that focuses solely on performance metrics without considering data sensitivity or regulatory mandates would be professionally unacceptable. This failure stems from a lack of due diligence regarding data governance and privacy obligations. For instance, if the monitoring system collects personally identifiable information, PI, or protected health information, FI, without proper anonymization, consent mechanisms, or access controls, it directly violates regulations such as HIPAA or state-level privacy laws. Such an oversight could lead to significant fines, reputational damage, and loss of customer trust. Another incorrect approach might involve implementing generic security measures that are not tailored to the specific risks identified within the big data environment. While security is crucial, a one-size-fits-all strategy often leaves gaps. If the monitoring system's data is not adequately protected against unauthorized access or exfiltration, and this data falls under regulatory protection, the organization would be in violation. This highlights a failure to conduct a thorough risk assessment and implement controls commensurate with the data's sensitivity and regulatory classification. The professional decision-making process for similar situations should involve a multidisciplinary approach. First, clearly define the scope of data being monitored and its regulatory classification. Second, conduct a comprehensive risk assessment, identifying potential threats and vulnerabilities related to data privacy and security. Third, design and implement architectural controls and operational policies that align with regulatory requirements and best practices for data protection. Fourth, establish a robust monitoring and auditing framework to ensure ongoing compliance and identify any deviations. Finally, foster a culture of compliance and data ethics throughout the organization, ensuring that all stakeholders understand their responsibilities. Question 15. Analysis of the risk assessment process for a new IBM big data and analytics platform handling sensitive customer financial data. What approach best ensures comprehensive identification and mitigation of potential threats throughout the architecture's lifecycle? Option A. Focus exclusively on technical vulnerabilities, ignoring operational and governance risks. Option B. Delegate the entire risk assessment to a single IT security specialist without broader stakeholder input. Option C. Conduct a single, comprehensive risk assessment only after the entire platform is fully developed and deployed. Option D. Implement a phased, iterative risk assessment integrated into each stage of the architecture lifecycle, prioritizing risks based on impact and likelihood, and involving cross-functional stakeholders. The correct answer is C. Conduct a single, comprehensive risk assessment only after the entire platform is fully developed and deployed. Explanation: scenario analysis. This scenario presents a common challenge in big data and analytics architecture, balancing the need for comprehensive risk assessment with the practical constraints of project timelines and resource availability. The challenge lies in identifying and prioritizing risks effectively without becoming paralyzed by analysis or overlooking critical vulnerabilities. The organization's reliance on a new, complex data platform for sensitive customer information amplifies the stakes, as a failure in risk management could lead to significant financial, reputational, and regulatory repercussions. The pressure to deliver the platform quickly adds another layer of complexity, potentially tempting stakeholders to cut corners on risk assessment. Correct approach analysis. The correct approach involves a phased and iterative risk assessment process that aligns with the big data and analytics architecture lifecycle. This methodology ensures that risks are identified, analyzed, and mitigated at appropriate stages, from initial design through deployment and ongoing operation. It prioritizes risks based on their potential impact and likelihood, focusing resources on the most critical threats. This approach is best professional practice because it is proactive, systematic, and adaptable. It aligns with established risk management frameworks, e.g., ISO 31000 principles, which are foundational to many regulatory expectations regarding data governance and security, by emphasizing continuous improvement and integration of risk management into all project phases. This ensures that the architecture is designed with security and compliance in mind from the outset, rather than as an afterthought, thereby minimizing the likelihood of breaches and regulatory noncompliance. Incorrect approaches analysis. One incorrect approach is to conduct a single, comprehensive risk assessment only after the entire big data platform has been fully developed and deployed. This is a reactive strategy that fails to identify risks early in the design and development phases. Regulatory and ethical failures here include a disregard for due diligence in protecting sensitive data, potentially violating data protection principles that mandate security by design. It also increases the likelihood of costly rework and delays if significant risks are discovered late in the project lifecycle. Another incorrect approach is to focus solely on technical vulnerabilities, such as software bugs or network security, while neglecting operational and governance risks. This narrow focus overlooks critical areas like data quality, access control policies, and compliance with data privacy regulations. Ethically and regulatorily, this is a failure to address the holistic nature of data risk, which extends beyond technical aspects to include human factors and policy adherence. Such an approach could lead to breaches of privacy or misuse of data, even if the technical infrastructure is secure. A third incorrect approach is to delegate risk assessment entirely to a single individual or a small, isolated team, without involving key stakeholders from business, legal, and compliance departments. This siloed approach can lead to incomplete risk identification and a lack of buy-in for mitigation strategies. It fails to leverage the diverse expertise needed to understand the full spectrum of risks, from business impact to legal liabilities. This can result in a risk assessment that is technically sound but operationally or legally deficient, creating significant compliance gaps and potential regulatory penalties. Professional reasoning. Professionals should adopt a risk-based, life-cycle-aware approach to big data and analytics architecture. This involves 1. Establishing a clear risk management framework aligned with organizational policies and relevant regulatory guidelines. 2. Integrating risk assessment activities into each phase of the architecture lifecycle, from conceptualization and design to implementation, deployment, and ongoing operations. 3. Prioritizing risks based on a consistent methodology that considers both the likelihood of occurrence and the potential impact, financial, reputational, legal, operational. 4. Ensuring broad stakeholder involvement to capture diverse perspectives and foster shared responsibility for risk mitigation. 5. Implementing a continuous monitoring and review process to adapt to evolving threats and changes in the data environment. This systematic and collaborative approach ensures that risks are managed proactively and effectively, safeguarding the organization's assets and ensuring compliance. Question 16. The performance metrics show that the new big data analytics platform is delivering insights significantly faster than the previous system, but there are concerns about potential data quality issues and the security of sensitive financial information being processed. Which approach best aligns with regulatory expectations for risk assessment in this scenario? Option A. Prioritize the speed of insight delivery by temporarily deferring detailed data validation and security checks until after the initial reporting cycle is complete. Option B. Rely on the experience of the data engineering team to make ad hoc judgments about data quality and security risks as they arise during the processing. Option C. Implement a comprehensive risk assessment framework that identifies, analyzes, and mitigates potential threats to data integrity, confidentiality, and availability, ensuring that the speed improvements do not compromise regulatory compliance or data accuracy. Option D. Focus solely on optimizing the technical performance of the analytics platform, assuming that the underlying data is inherently reliable and secure. The correct answer is C. Implement a comprehensive risk assessment framework that identifies, analyzes, and mitigates potential threats to data integrity, confidentiality, and availability, ensuring that the speed improvements do not compromise regulatory compliance or data accuracy. Explanation. This scenario presents a professional challenge because it requires balancing the need for rapid data processing and insights with the imperative to maintain data integrity and comply with regulatory requirements for risk assessment in a financial context. The pressure to deliver timely reports can lead to shortcuts that compromise the accuracy and security of sensitive financial data, potentially exposing the organization to significant financial and reputational damage, as well as regulatory penalties. The correct approach represents best professional practice because it prioritizes a systematic and documented risk assessment process. This involves identifying potential threats to data integrity, confidentiality, and availability, evaluating the likelihood and impact of these threats, and implementing appropriate mitigation strategies. This aligns with the principles of responsible data governance and the need to demonstrate due diligence in protecting financial information, which is often mandated by financial regulatory bodies. By proactively addressing risks, the organization can ensure the reliability of its analytics and maintain stakeholder trust. An incorrect approach that involves bypassing established data validation protocols to speed up processing is professionally unacceptable. This failure directly contravenes regulatory expectations for data accuracy and auditability in financial reporting. Such an action creates a significant ethical lapse by knowingly introducing potentially flawed data into critical decision-making processes, which could lead to incorrect financial assessments and regulatory noncompliance. Another incorrect approach, focusing solely on the technical performance of the analytics platform without considering the underlying data quality and security implications, is also professionally deficient. This oversight neglects the foundational requirements for reliable data analytics, particularly in a regulated environment where data integrity is paramount. It represents a failure to conduct a comprehensive risk assessment that encompasses both technical and data-centric vulnerabilities. A third incorrect approach, which involves relying on anecdotal evidence or assumptions about data quality rather than a structured risk assessment, is ethically and professionally unsound. This approach lacks the rigor required for sound risk management and can lead to a false sense of security. It fails to identify and address potential data-related risks, leaving the organization exposed to unforeseen consequences and regulatory scrutiny. Professionals should employ a decision-making framework that begins with clearly defining the scope and objectives of the data analytics initiative. This should be followed by a thorough risk assessment, identifying all potential threats and vulnerabilities related to data sources, processing, storage, and reporting. Based on the assessment, appropriate controls and mitigation strategies should be designed and implemented. Continuous monitoring and periodic reassessment of risks are crucial to adapt to evolving threats and regulatory landscapes. Transparency and documentation of the entire process are essential for accountability and compliance. Question 17. Stakeholder feedback indicates a strong desire to accelerate the deployment of a new big data and analytics architecture to gain competitive insights. Given this urgency, which of the following approaches to risk assessment is most aligned with foundational principles of responsible big data architecture design and regulatory compliance? Option A. Prioritize immediate deployment of the core analytics capabilities to demonstrate value, deferring a formal risk assessment until after the system is operational and initial insights are generated. Option B. Delegate the entire risk assessment process to the IT infrastructure team, assuming they possess all necessary expertise to identify and address all potential regulatory and business risks. Option C. Conduct a comprehensive, multi-stage risk assessment that integrates with the architectural design process, involving legal, compliance, and business stakeholders to identify and mitigate potential data governance, privacy, and security risks before and during the architecture's development. Option D. Implement a generic, one-size-fits-all risk assessment framework that can be applied quickly to the entire architecture, without deep analysis of specific data flows or potential use cases. The correct answer is C. Conduct a comprehensive, multi-stage risk assessment that integrates with the architectural design process, involving legal, compliance, and business stakeholders to identify and mitigate potential data governance, privacy, and security risks before and during the architecture's development. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for actionable insights from big data analytics with the imperative to conduct a thorough and compliant risk assessment. The pressure from stakeholders to deliver results quickly can lead to shortcuts that bypass critical due diligence, potentially exposing the organization to significant regulatory penalties and reputational damage. Careful judgment is required to ensure that the analytics architecture is not only effective, but also secure and compliant with relevant data protection regulations. The correct approach represents best professional practice because it prioritizes a proactive and comprehensive risk assessment before full-scale implementation. This aligns with the principles of data governance and responsible innovation, ensuring that potential risks associated with data collection, storage, processing, and analysis are identified and mitigated early. By embedding risk assessment into the foundational stages of the architecture design, the organization demonstrates a commitment to compliance and ethical data handling, which is crucial for maintaining stakeholder trust and avoiding regulatory scrutiny. This approach ensures that the big data and analytics architecture is built on a solid foundation of security and compliance, rather than retrofitting these considerations later, which is often more costly and less effective. An incorrect approach that focuses solely on rapid deployment without a preceding risk assessment fails to adhere to regulatory requirements for data protection and privacy. Specifically, it could violate principles of data minimization and purpose limitation if sensitive data is processed without a clear understanding of its risks and appropriate safeguards. Another incorrect approach that relies on generic risk mitigation strategies without tailoring them to the specific big data and analytics architecture, and its intended use cases would be insufficient. This would likely overlook unique vulnerabilities inherent in large-scale data processing, such as advanced persistent threats or complex data lineage issues. A third incorrect approach that delegates risk assessment entirely to technical teams without involving legal, compliance, and business stakeholders would create a significant governance gap. This would lead to a lack of holistic understanding of risks and an inability to make informed decisions that balance technical feasibility with business objectives and regulatory obligations. The professional reasoning process for similar situations should involve a structured approach to risk management. This begins with clearly defining the scope and objectives of the big data and analytics initiative. Subsequently, a comprehensive risk identification phase should be undertaken, involving all relevant stakeholders, to pinpoint potential threats and vulnerabilities across the entire data lifecycle. This should be followed by a thorough risk analysis to assess the likelihood and impact of identified risks. Based on this analysis, appropriate risk treatment strategies, e.g., avoidance, mitigation, transfer, acceptance, should be developed and implemented. Finally, continuous monitoring and review of the risk landscape are essential to adapt to evolving threats and regulatory changes. Question 18. Research into the foundational elements of a big data and analytics architecture for a financial services firm reveals a critical need for a robust risk assessment framework. Given the sensitive nature of financial data and stringent regulatory oversight, Which of the following approaches best ensures comprehensive risk identification and mitigation throughout the architecture's development and deployment lifecycle? Option A. Conduct a one-time, in-depth technical vulnerability scan at the architecture's inception to identify all potential security flaws and assume that addressing these technical issues will inherently cover all significant risks. Option B. Rely on anecdotal evidence and past project experiences to subjectively gauge potential risks, focusing only on those risks that have historically caused minor disruption, and deferring any detailed analysis until after the architecture is fully operational. Option C. Delegate the entire risk assessment responsibility to the development team, assuming they possess the complete expertise to identify and address all potential risks without external input or formal validation. Option D. Implement a comprehensive, multi-stage risk assessment process that begins with broad identification of potential threats across technical, operational, and business domains, followed by prioritization based on impact and likelihood, and concludes with the development and continuous monitoring of mitigation strategies. The correct answer is D. Implement a comprehensive, multi-stage risk assessment process that begins with broad identification of potential threats across technical, operational, and business domains, followed by prioritization based on impact and likelihood, and concludes with the development and continuous monitoring of mitigation strategies. Explanation: this scenario presents a common challenge in big data and analytics architecture, balancing the need for comprehensive risk assessment with the practical constraints of project timelines and resource availability. The professional challenge lies in ensuring that the risk assessment is thorough enough to identify potential threats to data integrity, security, and compliance, without becoming a bottleneck that paralyzes the project. Careful judgment is required to prioritize risks based on their potential impact and likelihood, and to select appropriate mitigation strategies that are both effective and feasible within the project's context. The correct approach represents best professional practice because it aligns with the foundational principles of responsible data governance and risk management, which are implicitly or explicitly mandated by regulatory frameworks governing data handling. Specifically, a structured and iterative risk assessment process, integrated throughout the project lifecycle, ensures that potential issues are identified and addressed proactively. This proactive stance is crucial for maintaining compliance with data protection regulations, such as those that might be relevant in a U.S. context, e.g., HIPAA for health data, or general principles of data privacy and security. It demonstrates due diligence and a commitment to safeguarding sensitive information, thereby protecting the organization from potential breaches, reputational damage, and legal penalties. An incorrect approach that focuses solely on identifying technical vulnerabilities without considering the business impact or regulatory implications would be professionally unacceptable. This failure stems from a narrow, siloed view of risk, neglecting the broader organizational context and legal obligations. Such an approach could lead to overlooking risks that, while not purely technical, could have severe consequences for data privacy or compliance. Another incorrect approach, which involves conducting a superficial risk assessment to meet a minimum compliance checkbox without genuine analysis, is also professionally unacceptable. This demonstrates a lack of commitment to data security and privacy, potentially exposing the organization to significant risks that were not adequately identified or mitigated. This approach violates the spirit of regulatory requirements, which aim to ensure robust data protection, not just perfunctory adherence. The professional decision-making process for similar situations should involve a phased approach to risk assessment. This begins with a broad identification of potential risks across technical, operational, and business domains. Subsequently, these risks should be prioritized based on their potential impact and likelihood, using a defined risk matrix. Mitigation strategies should then be developed and implemented, with ongoing monitoring and reassessment throughout the project lifecycle. This iterative process ensures that the risk assessment remains relevant and effective as the big data and analytics architecture evolves. Question 19. System analysis indicates that a new big data and analytics architecture is being designed to process sensitive customer financial data. The project team is under significant time pressure to deploy the solution. Which of the following approaches to risk assessment best aligns with foundational principles for establishing a robust and compliant data architecture? Option A. Focus the risk assessment exclusively on identifying potential cybersecurity vulnerabilities, as this is the most immediate and visible threat to financial data. Option B. Conduct a comprehensive documented risk assessment that identifies, analyzes, and prioritizes potential threats across technical, operational, privacy, and compliance domains, integrating findings into the architecture design and mitigation plans. Option C. Rely on the lead architect's extensive experience to identify the most probable risks, assuming that common threats have been adequately addressed in previous projects. Option D. Perform a high-level risk assessment during the initial planning phase and defer detailed analysis and mitigation planning to a later stage, once the core architecture is established. Correct answer is B. Conduct a comprehensive, documented risk assessment that identifies, analyzes, and prioritizes potential threats across technical, operational, privacy, and compliance domains, integrating findings into the architecture design and mitigation plans. Explanation. Scenario analysis. This scenario presents a common challenge in big data and analytics architecture, balancing the need for comprehensive risk assessment with the practical constraints of project timelines and resource availability. The challenge lies in identifying and prioritizing risks that could impact the integrity, security, and compliance of the data architecture, especially when dealing with sensitive customer information. A superficial or incomplete risk assessment can lead to significant vulnerabilities, regulatory penalties, and reputational damage. The pressure to deliver quickly can tempt teams to cut corners on crucial due diligence, making a structured and thorough approach essential. Correct approach analysis. The correct approach involves a systematic and documented process for identifying, analyzing, and evaluating potential risks to the big data and analytics architecture. This includes considering various risk categories such as data security, data privacy, data quality, operational resilience, and regulatory compliance. A key element is the prioritization of risks based on their likelihood and potential impact, allowing resources to be focused on the most critical threats. This aligns with best practices in enterprise risk management and is implicitly supported by regulatory frameworks that mandate due diligence and risk mitigation for data handling. For instance, in a U.S. context, frameworks like NIST Cybersecurity Framework and principles embedded in regulations like GDPR, if applicable to data processing, or CCPA, emphasize a proactive, risk-based approach to data protection. This methodical approach ensures that potential issues are addressed before they materialize, safeguarding the organization and its stakeholders. Incorrect approach is analysis. One incorrect approach is to rely solely on anecdotal evidence or past experiences without a formal, documented risk assessment. This is professionally unacceptable because it lacks objectivity and may overlook emerging threats or unique aspects of the new architecture. It fails to meet the implicit requirement for due diligence and can lead to significant regulatory or ethical failures if a critical risk is missed. Another incorrect approach is to conduct a risk assessment that only focuses on technical vulnerabilities, neglecting broader concerns like data privacy, ethical data usage, or compliance with specific data protection laws. This is a failure because modern data architectures must consider the full spectrum of risks, including those related to how data is collected, processed, stored, and shared, and the potential impact on individuals' rights and privacy. Such a narrow focus can result in noncompliance with data protection regulations and ethical breaches. A third incorrect approach is to perform a risk assessment that is not integrated with the overall project lifecycle or business objectives. Risks identified in isolation, without considering their impact on business operations or strategic goals, are less likely to be effectively mitigated. This can lead to a disconnect between risk management efforts and actual business needs, potentially resulting in wasted resources or the implementation of ineffective controls. Professional reasoning. Professionals should adopt a decision-making process that begins with understanding the scope and objectives of the big data and analytics architecture. This should be followed by a structured risk identification phase, drawing on various sources including threat intelligence, regulatory requirements, and expert knowledge. Risk analysis and evaluation should then be performed to understand the likelihood and impact of identified risks. Crucially, mitigation strategies should be developed and prioritized based on the risk assessment, and these strategies must be integrated into the architecture design and implementation plan. Continuous monitoring and review of risks are also essential to adapt to evolving threats and business needs. This systematic, documented, and integrated approach ensures that risk management is a proactive and effective component of the architecture development process, aligning with professional responsibility and regulatory expectations. Question 20. The assessment process reveals that the organization is eager to leverage advanced analytics on a newly acquired dataset containing customer demographic and transactional information. However, there is no documented process for evaluating the potential risks associated with this data before integrating it into the proposed big data and analytics architecture. Which of the following represents the most responsible and compliant initial step in addressing this situation? Option A. Prioritize the selection of the most advanced analytics tools, assuming that the technology itself will mitigate any inherent data risks. Option B. Immediately begin data ingestion and exploration to understand the data's characteristics, assuming that standard security protocols will suffice. Option C. Proceed with the architectural design, focusing on scalability and performance, and address any identified data risks during the implementation phase. Option D. Conduct a thorough risk assessment of the customer data, considering its sensitivity, regulatory implications, and potential threats, before finalizing the architectural design. Correct answer is C. Proceed with the architectural design, focusing on scalability and performance, and address any identified data risks during the implementation phase. Explanation. This scenario presents a professional challenge because the organization is attempting to implement a new big data and analytics architecture without a foundational understanding of the potential risks associated with the data itself and its processing. The challenge lies in balancing the drive for innovation and data utilization with the imperative to protect sensitive information and comply with relevant regulations. Careful judgment is required to ensure that the architecture is not only technically sound, but also ethically and legally robust. The correct approach represents best professional practice because it prioritizes a comprehensive risk assessment before architectural design. This aligns with the principles of data governance and responsible data handling, which are implicitly or explicitly mandated by regulatory frameworks governing data privacy and security. By identifying potential threats and vulnerabilities early, the organization can proactively build in appropriate controls and safeguards, thereby minimizing the likelihood of data breaches, unauthorized access, or noncompliance. This proactive stance is more cost-effective and ethically sound than addressing issues after they arise. An incorrect approach that focuses solely on the technical capabilities of the big data platform, without considering the nature of the data or its intended use, represents a significant regulatory and ethical failure. This oversight can lead to the mishandling of sensitive information, potentially violating data privacy laws and eroding customer trust. Another incorrect approach, which involves delaying risk assessment until after the architecture is deployed, is equally problematic. This reactive stance increases the exposure to risks and can result in costly remediation efforts, legal penalties, and reputational damage. It demonstrates a lack of due diligence and a disregard for the principles of secure and ethical data management. Professionals should employ a decision-making framework that begins with understanding the business objectives and then systematically identifies the data involved, its sensitivity, and the potential risks associated with its collection, storage, processing, and dissemination. This should be followed by a thorough risk assessment that considers both technical and non-technical threats. Based on the risk assessment, appropriate controls and architectural design choices should be made to mitigate identified risks. Continuous monitoring and periodic reassessment of risks are also crucial components of this framework.